So here's an example of the kind of problem that I talked about in our last video. What we're going to do is find the equation of the line tangent to the function f of x equals x cubed minus 2x minus 4 at x equals 3. Now by x equals 3, what we're really saying here is that this value right here is essentially taking on the role of a. So what we're going to do is set up our two different expressions that we have for what we referred to in the last video as f prime of 3. So the two possibilities are we can take the limit as x approaches 3 of f of x minus f of 3 over x minus 3. Or we can set up the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. What I'm going to do is set up both of these expressions, and then we'll evaluate both. So in the first case, this would be the limit as x approaches 3 of f of x. We simply recopy the function, x cubed minus 2x minus 4. Now as far as f of 3 is concerned, we would have to actually go back to the original function and plug in x equals 3. So we'll point out f of 3 is going to be equal to 3 cubed minus 2 times 3 minus 4. That'd be 27 minus 6, which is 21, minus 4, which is 17. Now what I'm going to do is jump over here for a moment and finish setting this one up. Then we'll just jump back to the first one and evaluate that one completely. So f of 3 plus h says replace all of your x's with a 3 plus h. So this will be 3 plus h, quantity cubed, minus 2 times 3 plus h, minus 4, minus f of 3, which we already got from back here, which was 17. This is all going to be divided by h. Now there are advantages and disadvantages to both of these. This one is going to require factoring, and this one is going to require expanding, both of which are doable using techniques of algebra. In the first case, limit as x approaches 3 of, your numerator is x cubed minus 2x minus 21. Denominator is x minus 3. You'll notice that if we attempt to use the direct substitution property, we'll get 27 minus 6 minus 21 by plugging in x equals 3, which is 0, over 3 minus 3, which is 0. So we'll have to use the techniques that we had previously talked about. Because we have a polynomial divided by a polynomial, we'll need to factor. The trick is factoring this numerator. Now we know from the factor theorem and from those previous sections that because we plugged in x equals 3 and we got a 0 in both the numerator and denominator, I should be able to factor out an x minus 3 from both the numerator as well as the denominator. The problem is trying to figure out what's left after I factor this out. For that, I'm going to use a synthetic division. We'll call this one an algebra aside. And I'm going to do a synthetic division. We're dividing by x minus 3, so my root is 3. And in order, we would need our x cubed, x squared, x to the first power, and constant terms. So the original polynomial was 1x cubed, 0x squared, minus 2x, and minus 21. If you need to review synthetic division, please let me know, and I will point you to the appropriate video. Drop the 1 below the line, multiply 3 times 1, we get 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 2 plus 9 is 7. 3 times 7 is 21. Negative 21 plus 21 is 0. We like seeing a remainder of 0. That means that we've done this correctly. Our quotient can now be interpreted as this is our x squared term, this is our x term, and this is our constant term. We can interpret this as x squared plus 3x plus 7. Then we get to the good stuff, actually canceling out the x minus 3's, leaving us with the limit as x approaches 3 of x squared plus 3x plus 7. At this point, we can apply the direct substitution property and get 3 squared plus 3 times 3 plus 7. That is 9 plus 9 plus 7. That is a slope of 25. Now, if you like this, if it speaks to you, great, wonderful. That'll work out just fine. However, getting comfortable with both of these techniques is going to be important, so let's do that. Now, I am going to skip the step of the algebra behind expanding this, but please know that this is writing down 3 plus h times 3 plus h, foiling those together, then multiplying by an additional factor of 3 plus h. The result is 27 plus 9h. Wait, is that right? No. No, it's not. Maybe I shouldn't have skipped this step. Maybe I should brush up on this myself. There we go. 27 plus 27h plus 9h squared plus h cubed. Then we distribute the minus 2. We'll get minus 6 minus 2h minus 4 minus 17. All of this is still over h. Now, if we were to combine like terms at this point, I notice that we would have a 27 minus 6 minus 4 minus 17. Those actually cancel each other out completely. We also have a 27h minus 2h. That'll be 25h. We also have 9h squared and an h cubed. All of this is still over h. There is one of two different mindsets you can get into here. Either factor out a common factor of h from the top, or divide each of the individual terms by the h in the denominator. So regardless of whether it's the distributive property or factoring, you are going to wind up with the limit as h approaches 0 of 25 plus 9h plus h squared. Applying the direct substitution property and allowing h to go to 0, the latter two terms will cancel out completely, leaving us with a slope, an instantaneous rate of change, of 25, which matches what we got using the other technique. So at this point we know that the slope of our tangent line is equal to 25, and that we have the ordered pair 3, 17 associated with this. Once you have this slope and this point, plug it into the point-slope form of a line for your answer. So this will be y minus 17 is equal to 25 times x minus 3. If you would like to perform other alterations to it after that, you're welcome to do so. However, anything that you do after this is purely cosmetic.